my name is Desiree Robinson, and today I am presenting about the life cycle cost analysis in pavement. So we'll go over like an introduction to what the life cycle cost analysis is, the life cycle, which is basically like how it works, the equipment costs, how it applies to the state of Texas, and some questions that you may have. So life cycle cost analysis in pavement is basically like a process for evaluating the total economic worth of pavement designs. And then it takes into account like initial costs and future costs over the life of the project. So the life cycle, which is basically how it works, first you select analysis period. So it's a length of time for which competing options are evaluated. And usually that's about like 40 or 50 years. And then you select the discount rate, which is the interest rate minus the inflation rate. Then you estimate the initial agency cost. So only the initial agency costs that are different among the alternatives. So if they're the same, then you don't really need to estimate those. Estimate user costs, which is me, you, anyone else who drives. And then these are costs incurred by users of the roadway over the analysis period. And then estimate future agency costs. So you have to consider maintenance and operation as well as rehabilitation costs and how long it will take. All of this stuff will go into the estimation of the roadways. And then you're going to estimate the residual value. So the net value of the pavement, if it's recycled at the end of its life, or the value of the remaining service at the end of the analysis, or the value of the existing pavement as a support layer for overlay at the end of the analysis period. So whichever option, how the road, what's going to happen to the road at the end of its life, that's the option you'll choose. And then you compare alternatives, and then you determine the best value alternative. And that's how you will know which one gives you the best value. The equipment that is used to run the life cycle cost analysis, people use spreadsheet software or proprietary software. There's a lot of different softwares. It depends on the state, depends on the company. And then they value by deterministic and probabilistic. So deterministic is a single defined value is assumed and used for each activity. So it's like the same across the board. And then probabilistic is the variability of each input is accounted for and used to generate a probability distribution for the calculated life cycle cost. And so you could see like the difference in the deterministic and probabilistic results. So if you use concrete or asphalt, it's basically calculated at a set rate when you're doing deterministic, and then the probabilistic results when doing concrete versus asphalt, it's going to be calculated using a rate due to inflation and material costs. And this is an example of like the FHWA real cost results. So that's the Federal Highway Administration. And that's just the software. The FHWA real cost results is the software. And so this software is free to download and use. It's a public tool that's provided by the Federal Highway Administration. How this applies to Texas, the Texas Department of Transportation uses life cycle cost analysis to quantify total cost of alternative pavement designs over an asset's lifespan. So the spans are at least 40 to 50 years for new pavements, and then it captures multiple maintenance and rehabilitation cycles. This helps engineers choose between flexible asphalt or rigid, which is concrete pavements for new construction and rehabilitation based on like long-term data that they've collected for hundreds of years. And it also demonstrates systematic maintenance drastically reduces the total cost of ownership. So that just means it's better to like maintain the road along the way rather than replace the road at the end of its lifetime. And then it also uses sophisticated frameworks, including the Federal Highway Administration road cost software, to model different scenarios probabilistically and account for uncertainties in inflation, material costs, and traffic. Preventative versus reactive maintenance. The life cycle cost analysis highlights that spending money on pavement preservation early is much cheaper than letting the road deteriorate, where a full reconstruction is needed, and it extends the pavement life and lowers the life cycle cost. Agencies use software like FHWA's road cost to compare different designs. And then while concrete has a higher initial cost, it often requires significantly fewer rehabilitation interventions and less maintenance over 40 years. So in the long run, it would be more cost effective. So today we learned that the analysis period is important and policy decision. It's an important policy decision that should consider the likelihood that a pavement alternative may have to be completely reconstructed, and then excellent pavement management system data is the best source of information in setting expected service lives or new pavement and rehabilitation projects. And then you also use great care when calculating salvage or residual value to include realistic figures, because you want your your quotes to be as accurate as possible. User costs can have a significant impact as well on the lifecycle cost analysis. But sometimes these are like well outside the responsibility of the agency, like TxDOT. And then uncertainty exists for many of the inputs in lifecycle cost analysis. So the probabilistic approach to lifecycle cost analysis can take uncertainty into account. It will give you a more accurate quote. So, a little quiz. I posted the answers with why is lifecycle cost analysis more effective than only considering the initial construction costs of a pavement project? And it's more effective because it considers all the costs associated with the pavement throughout its life. So just because a pavement option is cheaper in the beginning doesn't mean it'll be cheaper or more effective in the long run. And so this helps engineers find the option that provides the best value. What is the difference between deterministic and probabilistic? Deterministic, you have to remember, uses a single value for each input and produces one result. Probabilistic accounts for uncertainty by using a range of possible values and generating multiple outcomes. So again, TxDOT uses a probabilistic approach because factors like inflation and material change over time, and this makes the analysis more accurate and realistic. How can preventative maintenance, such as crack sealing, reduce the overall life cost of a pavement compared to reactive maintenance? Preventative maintenance, it helps preserve pavement conditions before major deterioration occurs, and crack sealing is inexpensive compared to full reconstruction. Maintenance can extend the pavement life and reduce total costs over the analysis period. This is where I found my information, and this is my presentation about life cycle cost analysis. Please let me know if you have any questions.